Hello friends, welcome to a new video on the rapid prototyping, which is the unit number 5 of the subject manufacturing process 3. Now in this lecture we will see what is meant by multijet or polyjet modeling and also about selective laser sintering. In multijet modeling, as usual, in the multijet modeling is a rapid prototyping method in which a plastic model is created in layers directly from the 3D CAD data using a print head with several linear nozzles. The wax-like thermoplastics are sprayed as a fine drops through a heated print head depending upon the resolution, here in case 300 dpi and higher, and polymerized by means of ultraviolet light. The method is very similar to that of inkjet printer, particularly suitable for high detailed and design prototypes. From this, true to detail original model castings can be produced in subsequent process if needed. Now, what is the process is all about? In polyjet or multijet modeling, either you can say as PGM for the polyjet modeling and multijet modeling as MGM, liquid acrylic polymers are layered on to build a platform with a print head with one or more nozzles and cured by exposure to ultraviolet lamps. The print head moves across the platform in paths predefined by a CAD model during the process until a layer is completely printed. The UV lamps are located directly on the print head and cure the plastic as soon as it has been applied. Now the most important part is here, the intensity of ultraviolet light is adjusted so that the uppermost layer does not cure completely. Remember this, the uppermost layer does not cure completely. Why for this? To achieve connection between the superimposed layers. Once the last layer has been printed, the UV lamp or ultraviolet lamp travels over entire component several times to complete curing process. Now what are the advantages of multijet modeling? Thermoplastic prototypes with good dimensional stability, restricted mechanical load, no geometrical restrictions, very fine details with high resolution, excellent surface quality and very short production times. So these are some of the advantages which are associated with multijet modeling. Now this is how the basic principle of multijet modeling or multijet printing works. Here you can see it is a header and here is the UV lamp. And these are the modeling part and the support plant. And in this how the multijet modeling is or occurs. Now coming to the next portion, selective laser sintering, or it is also called as SLS, which is an additive manufacturing technique that uses a laser, most probably that is CO2 laser, as the power source to sinter powdered material, typically nylon or polyamide, aiming the laser automatically at the points in space defined by 3D model, binding the material together to create a solid structure. During this process, tiny or small particles of plastic, ceramic or glass are fused together by heat from a high power laser to form a solid 3D object. The SLS process or selective laser sintering process was developed and patented in 1980 by Carl Deckard, who was undergraduate student at the University of Texas, and his mechanical engineering professor Joe Beeman. The selective laser sintering process begins with, as usual, conversion of customer generated 3D CAD data into sliced STL file, as we have already seen earlier, using proprietary software. Once the STL file is created, then it is sent to print on the selective laser sintering machine. Objects printed with SLS or selective laser sintering are made with powder materials, most commonly plastic such as nylon, which are dispersed in a thin layer on top of build platform inside the SLS machine. A laser, which is controlled by computer that tells it what object to print, pulses down on the platform, tracing a cross section of the object onto the powder. Now here again, next, the laser heats the powder either to just below its boiling point, or we can say that the sintering, or above boiling point or melting, which fuses the particle in powder together into a solid form. Once the initial layer is formed, the platform of the SLS machine drops, usually by less than 0.1 mm, exposing a new layer of powder for the laser to trace and fuse together. This process continues again and again until the entire object has been printed. When the object is fully formed, it is left to cool in the machine before removed. So it is important the object is kept in the machine itself to cool in the machine before it is removed. Now let us see how this SLS works, or what are the parameters. This is called the monitor of the computer on which you can make the CAD file. See this is the monitor on which you can make the CAD file, and this is connected to a machine. Here we can see as a, or call it as a 3D printer. So this is the monitor which is connected to the 3D printer. Okay. Now next on, here you can see the blocks, one for the powder left side and one at the powder right side, and these yellow marks, if you can see, these are the ejectors, and this is the platform which lowers down, Now what happens? This is the platform, see, you can see, which lowers down, and these are the two blocks for the powders. Now this is the thermal leveler which levels the powder which comes on the machine, Okay. Now we are using here CO2 laser which operates in this direction, and the powder, these are ejected upwards, and this CO2 laser acts in the downward direction, and the powder or the ejector which operates in the upward level. Now let us see how this process takes place. Suppose this is the CAD model, this is the part which we are going to produce. This is the CAD model. Now we are going to produce such type of the prototype here. Now what happens? Let us see, this is at this place. This is what? Leveler at this place. So the powder will come in this direction. So what the leveler does? This is a thermal leveler. It levels the powder in this form. This levels the powder in this form. Let us see here. This is the CO2 leveler, CO2 laser, and this is the powder, and this is, now this will act in this direction. Then what happens? This is the, it lowers down, and you will find over here you will find here the layer in this form. Layer in this form. Okay. Now next process, here in this place the powder will get ejected and this thermal level, select what will happen, it levels and again CO2 layer will form this one more level, and now here you can see here it gets fused itself, it gets fused here. This process goes on continuing unless the total build is formed. Total build is formed here. Now this is the final product. So unless and until this final product will complete, this process goes on and this final product will be produced with this process. Once this powder gets raised and the leveler will level, this CO2 laser will work on this, and in this way you will get the layers upon the layers, and this is the final product which we have already designed on the CAD software. So diagrammatic representation I have given, but priorly that I have explained the process with the help of the video. So unlike other methods of 3D printing, selective layer sintering requires very little additional tooling once an object is printed. What is the meaning of this? Object doesn't usually have to sanded or otherwise altered once they come out of the SLS machine. So no further post-processing is required. SLS doesn't require the use of additional support to hold an object together while it being printed. Such supports are often necessary with other 3D printing methods such as stereolithography or FD modeling that already we have seen earlier. As in case of stereolithography and fused depolation method, we have seen that supports models are required. But in this case, in SLS or selective laser printing, such supports are not required. So for this such stereolithography or fused deposition models are time consuming as compared to selective laser sintering process. Usually SLS companies can create prototypes that are stored digitally as .stl files which they can redesign or reprint as needed. Now what are the advantages? Selective laser sintering has proved to be particularly useful for the industries that need only a small quantity of objects printed in a high quality material. One example is the aerospace industry. Why aerospace industry? Because airplanes are built in small quantities and remain in service for many years. It isn't cost effective for the companies to produce physical models or spherical molds of the airplane parts. These molds would too expensive to make and would then need to be stored for the long period of time without being damaged or corroded. Because SLS machines can print in a range of high quality from flexible plastic to food grade ceramics, SL is also a popular method for 3D printing or 3D printing customized products such as hearing aids, dental retainers and prosthetics. So dear friends, today we have discussed about the two methods. So I have also provided you the video. If any doubt, you can revert me back, and for this thank you very much and stay safe, stay healthy. Thank you very much my dear friends.